Our next speaker is Dylan. You will remember Dylan from the first session when he did a great talk about adaphics. So he's now going to talk about something completely different.
All right, thanks everybody. I'm going to talk in my normal voice since it's no longer a lightning talk. So yeah, this is something completely different. This was kind of an accidental project, actually. The backstory for this project is basically that I was hanging out at my mother's place, which is about 6 miles as the crow flies from here, up in Butte Creek Canyon, and I was on a run, and I saw a spicebush that was, basically had opened up its receptacles. These are actually receptacles, not capsules or fruits. And the seeds were ripe. And I thought, well, we should try and grow some of these near my mom's place because it's a beautiful plant. It's the logo of our organization, after all. Props for Calicanthus. So yeah, I was really excited actually when I had this opportunity to do the lightning talk because it's our logo. We're right here in the land of Calicanthus. But in any case, I wanted to grow some of these below my mom's fish pond. It's a nice spot for it. So I grabbed a fistful of these seeds and I put them on the windowsill of our kitchen. This was about August or so, late August. And when I got up in the morning, about half of them were gone. Definitely at least half. And so that was weird. And the next day, when I got up, my mom reported to me as I was slurping my coffee that a wasp was in there trying to get the seeds. And she put a plate over it to trap the wasp. And in disbelief, I lifted up the plate, and sure enough, there was a Vespula yellowjacket under there, greedily eating the marginal organ on this Calicanthus akene. So nothing is as it seems in this system. This is not a seed, it's actually an akene. And the mystery just unfolded from there. Okay, so this is going to be a problem. I did this as a PDF, hoping it would minimize problems, but it looks like it just made them worse. So this is an extreme close-up of the Calicanthus receptacle. So for those of you who aren't familiar with Calicanthus, this probably looks like an invader from outer space. Earlier, someone alluded to the creatures that inhabit Mount Shasta and steal your mountaineering tools when you're up there, but this is another case of an outer space invader. So this is the ripe receptacle of Calicanthus. For those of you who don't know, Calicanthus, also known as spicebush, is the genus, is the only member of the family Calicanthaceae. It is a basal member of the clade that also includes things like cinnamon, the lauriaceae, or the laurier leaves. So it's a divergent family, and this genus is very unusual in its morphology of having these pods, but it's also found. This species is endemic to the California forested province, to California. There's also a species in the southwestern United States. It's pretty closely related, but not super. And there's a species that may or may not be a distinct genus in China. So it's one of these classic sort of Laurasian distributed plants, probably arrived in North America in a single migration event, and has probably been here 5 million years plus. But it's one of our classic paleoendemics. There's nothing else really like it in North America. When you're talking about two species together. But nobody had ever really looked at what exactly was happening with this plant. When you read the Jepson manual treatment, or the Flora of North America treatment, you hear that it just has a marginal organ on the akene. And it turns out that this marginal organ is pretty special. It is hoarded ravenously by Vespula wasps. Here are 2 akenes that I fed to these wasps, and they took them into their nest, fed them to their larvae. They removed the marginal organ of this seed, and these are the larvae here that eat it. And you can actually, if you capture the colonies live, you can actually feed this stuff to the larvae, and they really like it. So the obvious question was, what in the hell is going on here? And I'm no entomologist. I actually started in entomology, so I kind of have an inclination towards looking at insects and understanding what they're doing, particularly interactions with plants. And so this was kind of a fun project for me. So I spent the rest of the summer kind of bumming around Northern California trying to figure this out, visiting different populations of Calicanthus, trying to see what the wasps were up to. And the amazing thing that was within 5 minutes of arriving at any Calicanthus population, you would notice these wasps removing the akenes from the capsules or from the receptacles. So they're doing it everywhere. I actually transported some of these seeds to Idaho, and the Vespula there also do it. They really like them. And so I thought, well, the first step here is to analyze these things for the nutrient contents. And as you might have guessed, it turns out that this marginal organ is more than a quarter protein by dry weight. And if you're wondering, it compares favorably with things like cheese and beef, which would explain why the Vespula wasps, known colloquially as meat bees, would be interested in these seeds. They are scavengers of protein. Well, there's a whole guild of them actually. They're scavengers, the Vespula pennsylvanica that we have predominantly around here. There's also predators that go out and capture light insects, sting them, and bring them back to the nest. But most of the Vespula that you see visiting the Calycanthus are scavengers. So in a normal day, they'd be out there, picking apart a salmon carcass or trying to eat your hot dog from out of your mouth. If you grew up in Northern California, you're familiar with these wasps. They're in many cases considered a pest, but they are native. We don't have any non-native Vespulas in California outside of the Bay Area. So they are native, as annoying as they are. And I'm here to tell you that they might actually be interesting for a botanist in particular. So the next step in this project, I think we're about to do some gas chromatography. We're going to do some analysis of the volatiles coming off of these seeds, because the fact that they're 25% protein doesn't really explain how these wasps can find them almost invariably. I mean, I had this stuff in the back of my truck, and I would pull up to a field site, drop my tailgate, and there would be Vespula wasps trying to get inside my plant press. So whatever these seeds are doing, they're actively signaling the wasps. So we're interested in figuring out what that active signal is. It's not protein, because protein is not volatile. So there could be a signal involved, and it could be specific. The other question is this happening in the southeastern species of Calycanthus and down in the southeastern United States? And even more interesting, is it happening in the Chinese one? So I'm hoping this coming summer at the Congress in China, I'll get to find out. Oops. Okay, that's it.